Okay, so this is the second problem. This is problem 72 in the section we were looking at. So it says it defines f of x this way: it's x squared for x less than or equal to 2, and mx plus b for x greater than 2.
All right.
And it asks you to find m and b. Find the values of m and b that make this function differentiable everywhere.
So differentiable meaning that you can find derivatives everywhere.
Okay. Yeah, we haven't spent a lot of time yet on these definitions and what they mean, but that's right, you can find the derivative everywhere.
Alright, well...
This is an interesting problem because this we really haven't talked about this, but I still think you can figure this out.
I think the problem here, so let's see, we have a parabola, and then it stops at 2.
Right.
And then we're going to have a line going off somewhere.
Right.
So we're going to want it to go this way, so that it's still a function.
Mm-hmm.
Alright, well, the problem here is the point where the parabola ends and the line begins.
Okay. So what do you think you want to be true?
I think I want it to be continuous.
Alright. Okay. Why do you want it to be continuous there?
Because if there's gaps, I know that I can't find the derivative at that point.
Okay, very good. That's a great observation. So it's got to be continuous.
But if it's continuous, this corner is going to present problems.
Very good. So that means you're going to want something more than continuous. And in fact, they even said it. They want it to be differentiable.
Yeah.
So what do you think that means?
I think that means you can find the derivative. Or there is a derivative at every point.
That's right. That's exactly what it means. So what do you think that's going to mean in your picture if there's a derivative at that point?
Well, we need to have a point here that works, that has a derivative.
Okay. That's right. But what's that going to mean geometrically?
So there's the tangent line, like in terms of the tangent line?
Tell me.
Well, so we know the derivative is going to be constant along this line.
Right.
We know it's going to be 2x along here.
Okay.
But what is it going to be here?
That's a great question.
How do we make it so that we have a derivative here? Because all the corners on functions I've seen don't have derivatives.
That's absolutely right. If it has a corner, it won't have a derivative. You are absolutely right.
So we have to make it somehow so it doesn't have a corner. So maybe like we go off like that somehow.
Okay, so what's special about that line?
So it should kind of continue what the parabola would have looked like, but it goes straight.
Okay.
Maybe that line is the tangent line at 2. So it kind of approximates the shape of the parabola. Maybe it has the same slope as the tangent line at 2. Which is going to be 4. So maybe we could say we have y is 4x, and this is 0.24, so it's 4 times x minus 2. Here's y is x minus 4, or 4x minus 4. So maybe this works.
Okay. So, does that line pass through the point 2, 4?
Yes.
Okay. So that means what can, if, since that line passes through that point, what does that mean about this sort of function defined this way? Just only the fact that it passes through the point.
Well, it shouldn't affect this definition because this line can continue on down here. It's not part of the.
Well, right, but the function is defined this way.
Yeah.
So now the function, given that that line passes through that same point as x squared does, so what does that tell you about this function?
So it's both of these at x equals 2.
Okay. So the function has a certain property, and that property has a name.
What? That it's both of its definitions?
Yeah.
I haven't
What does
heard-
that mean about the function?
Hmm?
It means the function is continuous.
Oh.
It doesn't have a gap.
Okay.
Okay? Because if that line passed through a point up here, what would that mean?
That mean there'd be a gap. There'd be a gap between where the parabola ends at 2 and where the line starts somewhere up here.
And you said right in the beginning, in order to be differentiable, it had to be continuous. Okay, so you've got that. The line passes through the point. Now, how do you know it's differentiable? How do you know the derivatives from both sides are the same now?
Well, because from the parabola, you know, the derivative is 2x, and then we've got x equals 2 here, so the derivative is 4.
Okay.
And then for the line, the derivative is just the slope, and that's also 4.
All right. Okay, very good. Nice work. Good job.